Good day. Welcome to another lecture of Math 21. For today, we'll be discussing formal definition of a limit and continuity of functions. This lecture will be divided into 3 videos. In the first video, we'll be discussing the formal definition of a limit, and the second and third videos will discuss continuity at a point and continuity on an interval respectively. Let's proceed to the first topic. Recall that so far we have only discussed the intuitive notion of a limit. That is, if the limit of f of x as x approaches a is L, then f of x gets closer and closer to L as x gets closer and closer to a but not reach a. Or we can also say that the limit of f of x as x approaches a is L if we can let f of x be as close as we would like to L by taking values of x sufficiently close but not equal to a. So we will describe mathematically what it means to be closer and closer to L or closer and closer to A. First, let's look at this example. Let's consider the function f of x equal to 2x minus 1. Okay, for which values of x do we have this inequality? We just solved this inequality, so f of x is 2x minus 1, and this is less than 2 but greater than 0. Isolating x, we can add 1 to both sides of the inequality. We have 1 less than 2x less than 3. And dividing everything by 2, we have x less than 3 halves and greater than 1 half. Therefore, we say that this inequality is satisfied for all values of x such that this inequality holds. Okay? Let's look at another illustration. Now we consider the inequality f of x less than 3 halves but greater than 1 half. Again, we let f of x be equal to 2x minus 1 and we solve this inequality. So we can add 1 to both sides of the inequality. You have 3 halves less than 2x less than 5 halves. Again, dividing everything by 2, we have 3/4 less than x less than 5 over 4. Okay, so do you remember now how to solve inequalities? So to answer the question, we say that this inequality is satisfied for all x such that x is greater than 3/4 and less than 5 over 4. So given a positive number epsilon, for which values of x do we have this inequality? That is, f of x is less than 1 plus epsilon but greater than 1 minus epsilon. Sige, can you verify this inequality is equal to this absolute value inequality? Okay, so please check that. So again, we substitute the function 2x minus 1 to f of x. So we have 2x minus 1 less than 1 plus epsilon greater than 1 minus epsilon. Again, same as what we have done in the previous illustrations, we add 1. And divide everything by 2. So we have 1 minus epsilon over 2 less than x less than 1 plus epsilon over 2. Now we can write this in terms of absolute value. So this is equivalent to saying that the absolute value of x minus 1 is less than epsilon over 2. Okay, so to answer the question, for which values of x do we have this inequality? We say that inequality holds for all values of x such that the absolute value of x minus 1 is less than epsilon over 2. Okay, so why are we discussing or why do we need to use the absolute value function in here? Recall that in the one-dimensional system, okay, when you talk of the distance between 2 points, say R and S, the distance is just equal to the absolute value of R minus S. Pwedeng absolute value of R minus S or absolute value of S minus R. They should be equal. Okay. Remember, our goal is to describe what closer and closer means. So closer in terms of distance. So we will be using this formula for the distance. Okay, so in general, what have we done or what was the problem that we tried to solve in the three illustrations? That is, if you're given a function and given any positive number epsilon, we want to find delta. Okay, we want to find the delta such that the absolute value of f of x minus L is less than epsilon whenever the absolute value of x minus a is greater than 0 and less than delta. So this is the formal definition of a limit. Let f be a function defined on some open interval containing a except possibly at a. The limit of f of x as x approaches a is L, and we know that this is the notation if for every epsilon greater than 0, no matter how small, there exists a delta also greater than 0, such that if the absolute value of x minus a is greater than 0 and less than delta, then the absolute value of f of x minus L is less than epsilon. So comparing it with the intuitive notion of a limit, what are we saying? First, for every epsilon greater than 0, so if we choose an epsilon, no matter how small, say this is epsilon, this distance is epsilon, let's consider epsilon units from L. Okay, so let's consider this interval from L minus epsilon to L plus epsilon. Now, the definition says that if you set this epsilon, no matter how small, we can find a delta. Now, delta is the distance from A. Okay, this is delta units and this is delta units. Therefore, we can consider the interval from A minus delta to A plus delta. So, for every epsilon greater than 0, no matter how small, we can find a delta also greater than 0 such that if the absolute value of x minus a is less than delta, remember absolute value of x minus a is the distance of x from a, meaning your x is within this interval. Say this is your x. Of course, you can also choose your x somewhere here as long as it is in this interval, meaning its distance from a is less than delta. Then, the definition says that an f of x. Okay, if the limit exists, this is x, this is your f of x. And that f of x is close to L. Okay, meaning your f of x is within this interval. So let's use the definition to prove that the limit of 3x plus 2 as x approaches 1 equals 5. The proof for this involves two steps. First, we choose a value for delta. And then second, we verify that that chosen value of delta works or satisfies the definition. Okay? So first, we let epsilon be greater than 0. And our goal is to find delta such that, ano yung sabi sa definition? If the absolute value of x minus 1 is greater than 0 but less than delta, then the absolute value of f of x, our f of x in this example is 3x plus 2 minus L, so minus 5 is less than epsilon. Okay, so let's consider this inequality. Okay, so yung absolute value of 3x plus 2 minus 5, sige, lagay ko na lang note, is equal to the absolute value of 3x minus 3. Correct? Then you can factor out 3. And then the absolute value of 3 is still 3. So 3 times the absolute value of x minus 1. Okay, so going back to this statement, so if 0 is less than the absolute value of x minus 1, less than delta, then, or we replace this absolute value by 3 times the absolute value of x minus 1. So 3 times the absolute value of x minus 1 should be less than epsilon. Okay, now here, we can divide both sides by 3. We still have the same inequality. Okay, so what do we have? This says that the absolute value of x minus 1 is less than epsilon over 3. Therefore, comparing it with this inequality, we can take delta to be equal to epsilon over 3. So that is our chosen value for delta. Okay, so the next part is to verify that that delta works. Again, given any epsilon greater than 0, we choose delta to be equal to epsilon over 3. Going back to the definition, so it says that if the absolute value of x minus 1 is greater than 0 and less than delta, then the absolute value of f of x, let's rewrite that again. So f of x is 3x plus 2 minus the limit, which is 5. This is equal to 3x minus 3. And again, you can factor out 3, absolute value of x minus 1. Using this inequality for here is less than 3 times delta. And since delta is equal to epsilon over 3, so this is equal to 3 times epsilon over 3, which is equal to epsilon. That is, so let's just rewrite this. If 0 is less than the absolute value of x minus 1, less than delta, then the absolute value of 3x plus 2, or f of x minus L, is less than epsilon. And therefore, by the definition of the limit, the limit of 3x plus 2 as x approaches 1 is equal to 5.